So in the last video, we introduced the concept of marginal physical product. Well, we're going to dive into it a little bit deeper, and we're actually going to show you, go into a little bit more depth on the relationship between total physical product and the marginal physical product. So just to recover what marginal physical product is, marginal physical product is the amount of output you get from one more input. So this applies to any business, to any enterprise, to any product. You want to look at farm and ranch examples for the farmer ranch. So let's take a hayfield, for example. We could look at what will one more pound of fertilizer get us in output? What will one more inch of water for irrigating get us in terms of total yield or tons per acre on our particular operation? If we look at livestock, how will one more pound of feed get us in terms of rate of gain and output on our animals? How much will one more pound of feed get us in terms of pounds of live animals when we're going to sell it? How much will one more pound of corn get in terms of marbling for our livestock? It all deals with what is our input, one more input, how much more will that get us in our output? That is marginal physical product. And the key thing about it is you can apply it to any situation in business, and it's one more. How much will one more input? You keep hearing me say one more, but if you get that concept down that we're dealing with one more, it will help you out in understanding marginal physical product. So we know that an important relationship exists between total and marginal physical product. The slope of the total physical product curve is actually equal to the marginal physical product, or is approximately equal to the marginal physical product. So the marginal physical product shows the rate of change of the total physical product. Remember, we talked about that in the last video, that this marginal physical product is actually showing us the rate of change. Not only does it show us how one more input is going to get us in terms of output, it's showing essentially the rate of change for this output. So let's go ahead and look at these two graphs. I put up two graphs here. I put up the total physical product curve and the marginal physical product curve. If we look at how these graphs are laid out, we have labor use on the horizontal axis for both of them. Here we have output. Another word for output, or another way we can describe output, is total product or total physical product. Down here we have marginal physical product, so that change in output. And we line these two graphs up because it's going to show us a couple of key things. So the marginal physical product curve measured that rate of change in an output in response to the change in the use of input. So basically we're saying the same thing three different times, that the slope of the TPP curve is approximately equal to the marginal physical product curve. That's the rate of change of the total physical product curve. And it's also showing us that the rate of change of an output in response to a change in the use of an input. So there are three main stages of the marginal physical product curve. There is until the peak. So until we hit this peak of the marginal physical product curve. Until we hit that peak, we know that TPP is increasing at an increasing rate. So let's go ahead and draw that out. It would be right here. So these two graphs are actually lined up. So the total physical product curve up until this point is increasing. We can see that it's increasing, but it's also increasing at an increasing rate. We know that it's increasing at an increasing rate because our marginal physical product curve is increasing. So as long as that marginal physical product curve is increasing, we know that total physical product curve is increasing at an increasing rate. And that actually occurs up until this point, at point D, until the peak of marginal physical product. That's actually at this point. Then, after we peak on this marginal physical product curve, until that marginal physical product curve equals 0, we actually know that total physical product from here to here is actually going to be increasing, but at a decreasing rate. That as long as this marginal physical product curve is still positive, total physical product curve is increasing, but it's increasing at a decreasing rate because the rate of change is actually decreasing, as you can see from the marginal physical product values. And then after marginal physical product turns negative, then we actually see that total physical product actually begins to decrease. So after marginal physical product equals 0, total physical product actually begins to decrease. So let's just kind of go through this real quick. Let's imagine this example of, so we're dealing with a hypothetical company called Top Ag, and they're hiring on more labor, and they're producing, let's say that they're producing some smaller farmer implements, I should say. And we already discussed how if we go from this point to this point and we hire on 2 people, well, now 2 people are going to be more efficient, especially working less hours throughout the day, and they're going to get 3 units done rather than just 1 unit done. And that marginal physical product is actually going to be increasing up until this point. Well, what's causing it to increase? We'll stop and think about it this way. We hire on a 3rd person here. Well, now we can get 3 people in there, one of them working part-time, or maybe 3 of them splitting up their hours evenly, and now 3 people can be more efficient in that workspace than what 2 people can. So they can get more done per hour than what just 2 people could. And then we hire on, or that 3rd person actually works a few more hours. Well, then he's actually getting in the groove of things and starts working even faster. So think about working in your own shop, or working in a shop welding or fabricating anything. Maybe it's woodworking or whatever you like to do. If it's just you by yourself, well, you might have some difficulties moving some of the heavier pieces of equipment or maneuvering things around. Sometimes it's really helpful to have that 2nd person around. And then you get into that 3rd person. Well, that 3rd person, let's say they're working half a day. Well, about the time that they really get going, they're really getting efficient, well, that's whenever they quit for the day. So what if you kept them on a couple more hours and they actually start doing even more and they start becoming even more efficient? And then all of a sudden we're hitting this point where now we still get more done. Our output is still increasing. We see that our total output is still increasing up until this point, but they're not getting as much done per hour as they would have up here. Well, why might that be the case? Well, let's say you're working in a moderately sized shop, and now all of a sudden you're trying to add a 4th or a 5th person. Well, by the time you add that 4th or that 5th person, now you're starting to get a little bit more crowded. You can still get more done, but you don't have as much room to work, and you're starting to get in each other's way. Maybe you don't have as many tools, and the additional hours is actually yielding less, or 1 more hour of work is still gonna yield an output, but not as much as it was before. Then all of a sudden you get down here, and let's say at this point in time you've hired too many workers. They're getting in each other's way. They're using up all the tools. You can't get anything done. They're scattering tools around, and actually output decreases because you've actually got too many people in there. So that's how, in real life, we might be able to see how, or we can see how that total physical product curve could be increasing at an increasing rate, and then begin to increase at a decreasing rate, and then actually begin to fall. And we can see how marginal physical product can increase, peak, and then begin to fall, and then hits this point where it actually goes negative.